goal is to run this in a relatively interactive fashion. And so my sort of plea to you is to like speak early and often and ask your questions. One of the things I used to do in pre-pandemic times, if I ever got a chance to moderate a panel, is I would run the Q&A session first. So I would ask everybody in the audience to raise their hand and ask, why are you here? What are your questions? Collect all the questions and then start the panel. And it would keep the panelists on their toes, because the point was the audience is always pretty smart and they actually have real questions. So that'll be our hope for this as well. So a lot of you are doing really important work in this area, and so we want to benefit from that. And then one programming note, as Ulrich mentioned, is that not everyone can make this. So our hope is to make this a community resource. So we will be recording it so that for folks will be able to benefit from the information. So great. So feel free to keep adding and we'll keep track of the questions as folks come in. So with that, let's get started. Any question anybody has? Otherwise, I'm gonna dive into just giving a little bit of context on the point of this conversation and then go from there. So you guys want to load up our slide deck? Awesome. So I will say this is one of the nerdier topics that you can have as a AMA. And so let me just give like a little bit of context as to why we're having this. So Schmidt Futures, where I work, has a program called Learning Engineering. And one of our tracks inside that program is something that we call platform instrumentation. There's a lot built into that those words, which is and some of you have heard this from me before. One of the things that I worked on when I was inside the Obama administration, working on edtech and education R&D, was we would make a lot of analogies between education R&D and other forms of R&D. And so we would say, you know, what are ways that we are using both new methods, new platforms, and others to accelerate the pace of the research enterprise. And in other fields, there's a number of different ways that you can accelerate. You can develop new low-cost tools. You can build open source software. But one big way that you've seen major advancements in the research enterprise and other fields is to build common research infrastructure. Research infrastructure that you make a large investment on the front end and gives researchers the ability to actually design and run experiments. The analogy we always make is like, there was a time when astronomy involved everyone designing their own telescope. And now we have these large instruments that collect huge amounts of data and images, and astronomers actually spend their time designing really good questions to and analysis of that data. And so the question is like, what is the modern day telescope for education R&D? And one of the hypotheses we've been testing, working with folks like Neil, which we'll get into, is the idea that one way we could be starting to emulate this infrastructure is to actually go where learners already are, which is that large numbers of learners in the past decade have actually started to arrive on digital learning platforms. And you can actually use these platforms as to both test different ideas for how humans learn and improve various learning strategies. And they could serve as infrastructure for running rapid R&D experiments. And so in some ways they could be this collider or telescope for experimentation. The question is, how do you actually do that? How do you actually take something that is largely designed to be a delivery service and actually also have it serve as something where you can run experiments? And so that's where instrumentation comes in. We borrowed heavily from our friends at Carnegie Mellon, where under the OLI, they actually first came up with this idea, at least when I was exposed to it, of not only designing a course, but actually having the course itself function as a lab where you could test new ideas for how to improve the course. And so one of the things we've been doing a lot over the past 2 years is working with large scale digital learning platforms and saying, what would it take for you to have the steps to be able to instrument that platform so that researchers, dozens, and if not down the road, hundreds of researchers can use it to design and launch experiments, collect data, and improve our fundamental understanding of learning and be able to drive it. Just to sort of flag, this sits alongside two of our other strategies, which is the other one is focused on talent, which is how do we drive the best computational talent in this space, and the other one is, how do we then shape the market so that these insights and this talent can actually build, both game-changing innovations and others, and have those be able to actually deliver, and what are ways that we can work with the public sector to be able to drive that. So if we could keep going to the next slide. So a number of this I sort of covered as to that, both some of the things that we talk about when we say the word learning engineering, which is an idea that really comes out of the Carnegie Mellon around how do we actually take every process of learning and actually think about it as a partially engineered system, and where one can actually run lots of experiments and improve. And the reason I think this is a powerful idea, and I've drunk the Kool-Aid on it, is I'll just take like a very simple example that I use all the time, which is take the idea of something called spaced repetition. So spaced repetition is a learning science idea that says that we take something from short-term memory and long-term memory by actually not only learning it, but then engaging in recall and trying to apply it sometime down the road. And the question is like, when should you repeat back and come back to a concept you've learned before? And lots of spaced repetition studies show that you should come back to content that you learned before. But if you were to read a number of these papers, you wouldn't know whether I should assign that homework that night as homework, or whether I should come back to it in a week, or I should come back to it in a month, whether I should come back to it based on what the content is, based on the learner. So like there's 100 questions around implementation around an idea that is pretty well tested when it comes to learning science. And so I do think we need to have an experimentation layer that tests these ideas and starts to help us build a system where we can actually apply these insights at scale over time. So we can quickly go to the next slide. So I think the question, I think, for the session today is starting to then dig into what does this actually look like, and what are a lot of the questions that come up when you're actually trying to implement it. So, as I said, the goal is how can you run these experiments where you could actually do, whether we call them, A/B, sort of A/B testing to, other sort of experimental methods, but where you can actually see actual evidence of something working. So, and then apply those insights against the core product that you're applying it on, but also have a better understanding of who it works and for whom. But then how do we actually make this work for researchers? So a researcher can actually design the experiment. They can actually know what the actual underlying data that sits inside that platform, and then they can actually get that data back and actually publish. And then obviously there's questions around, how do you do that in a way that protects the privacy of the learner and of everyone involved? How do you do that in a way that you can actually, sometimes researchers are able to have access to this data, but it's very one-off. So how do you allow many researchers to be able to do this? And how do you make this into something that fits into the, the system constraints of the platforms that work in there? And so this ends up being in an iterative process. And we've got, I saw Steve Ritter here, and Carnegie Learning, I think, has been doing a bunch of this work. So we have other experts who've been working on this, and I definitely hope that they sort of chime in and talk about how they're sort of managing for these as well. But I think it'd be great to hear from Neil when I pass the baton for how he's been sort of managing some of these. So we can go to the next slide. So why don't we just quickly run through at least some of the ways we've sort of seen this just in the past year and a half of sort of tracking and working on this space. So we go to the next slide. So Steve can say a lot more about this, both in the chat, and then I might call on him when we get to the open piece. But Carnegie Learning is a really large platform. My old data point, I'm sure that it's gotten way bigger. Pre-pandemic was, I used to say they have 400,000 users. I don't actually know their most recent user numbers. But Carnegie Learning is a large provider. They work with lots of school districts. They're in lots of classrooms. And the question is like, what are the, how does one actually, if you're a researcher, work with Carnegie Learning to design and run an experiment on the Carnegie Learning platform? Obviously, one version of this, and this has happened before, is, call up Steve Ritter and run an experiment. But I think the piece that I think Steve has really worked on over the past 18 months is how do we start to actually build this as a system? And so there's, they both developed the, yes, email does work better. But they've both developed a system by which you can design experiments in ways that teachers will buy into. So, no child is being left behind in the system. Eventually everyone gets the intervention. They have they have all these interesting innovations, like a hotline that you can call. You have a question, how to design these conditions. But then they've also actually developed a bunch of these templates and tools and actually open source that that method under Upgrade, which has actually been used by one or more other platforms. So I think it's a really interesting example of both building the tooling and having it spread out. I was actually on a conversation with another platform provider this morning, and they were like, "Oh, we plan to integrate Upgrade in our work this year." So I think Steve is having an impact both in his own work, but also in the broader community. So I think part of my hope for a session like this AMA is I don't think we benefit from doing all of this stuff inside our hood and not telling anyone else about it. I mean, in some ways, some of this came about. Neil had invited me to an AI ed conference, and he was doing the classic Neil Heffernan thing of just walking me around the conference, and he sat me down at a table, and I think it was Neil, Ken Katinger, Steve Ritter, and others, and they all just started talking about different ways they were forking students on their platform to create design conditions for experiments, and all of them were using a different method. Like, oh, we're using Google Experiment, we're doing this. And I said, well, have any of you ever sat down and compared methods and figured out what open code you might want to use? And out of that, Steve Ritter ended up doing a workshop on this, and a number of these tools exist. So I think there's real value in folks talking about how they're running and designing experiments, because I don't think there's yet one big vendor that's solved this problem for the field. Why don't we keep going to the next slide? This is another one that we've worked with. This is from Ben Motz at University of Indiana, and this is built, on top of Canvas. One of the things I find really interesting about this is, Ben's goal is to make a tool that can both sit on a number of different LMSs, but also one that actual teachers will be able to use. I mean, one of the things that I think there's a real value in being able to build this experimental architecture is we can actually democratize who can run an experiment. I think there's a huge amount of implicit knowledge that teachers have. And right now we say to teachers, hey, if you're really interested in running experiments, pair up with a researcher or go get a PhD. And I think there are actually developing systems by which they can actually use that expertise to design experiments directly would be really valuable. And maybe Neil can talk a little bit about how teachers have been doing that on top of the ASSISTments platform as well. Why don't we go to the next slide? I think we're at the end. So if we could pass to Neil, and then again, we've been tracking sort of the questions I've been seeing as people have been coming in. And so why don't we just have Neil talk a little bit about the ASSISTments experience, and then we'll go into full, everyone can see each other and start to work through the questions. So on to you, Neil.
Okay, sounds great. I'm glad you actually shared that stuff from Steve Ritter and Ben Motz. Then actually Moats came to my class and was sharing the terracotta stuff. And so I'm happy to talk about eTrials. I saw someone actually in the chat was kind of saying, hey, I'd like to try eTrials. I saw Karen actually from Columbia. But I'm also trying to make my remarks to other people that actually have platforms and thinking about actually how they could do stuff with them. To be honest, actually, Kumar actually has been kind of pushing me to be like, hey, Neil, help other people that actually have platforms that aren't actually already doing experiments. And to be honest, I'm kind of proud of the fact that I helped 3 other actually platforms who I won't name, but actually I was like, you should go apply for the $2 million actually bid actually that happened last month at IES. And they're all bidding against me. I'm so committed to the fact that we have these platforms and we should be using them more intelligently, that I'm actually getting people to bid against me actually, because I think it's so important for us to use these platforms more broadly. Of course, luckily there is 5 people can win. Anyways, I'm Neil. I run ASSISTments. Okay, my wife and I created this thing, and so you'll see in these little boxes. ASSISTments is the name of the product. Okay, eTrials is the name of the A/B testing infrastructure. So I'm the professor at Worcester Polytechnic Institute. My wife, actually, Christina Heffernan. We both met teaching middle school mathematics. She actually runs the foundation known as very actually creatively named the ASSISTments Foundation. So that is us. What is ASSISTments? We're just blending actually the name assisting and assessing. That is assisting students while actually helping actually teachers assess where to focus attention and time. We have 20,000 actually odd teachers in all 50 states and 14 countries. I just spent the morning working with Mauritius, Rwanda, and one other African country I cannot actually name. It's well over 10 million problems actually this year, but I didn't bother updating that slide. And as you can imagine, actually during this pandemic, we've had a 10-fold actually increase in student usage and teacher usage. What is ASSISTments? Actually, in brief, but that's not the point of this talk. The point of this talk is how to use these platforms to do science. But in brief, we are a little different than many edtech platforms. So I'll just say one thing, which is teachers still are in charge. They make individual assignments. They create an assignment, kids go do it, teachers assess performance, and then they actually analyze some work together. That is, teachers are in charge. It's a teacher-paced tool. Kumar and I met each other actually when actually the results of the big efficacy trial that was done in Maine, that was done by actually SRI and Jeremy Rochelle, came to the White House and presented in 2016. And that's when I met Kumar when you were still at the Office of Science Technology Policy. And Jeremy came and presented these results. And huge randomized control trial, and actually the 3 main results were teachers reliably changed their practice. Actually, student learning actually went up on these standardized measures by a very meaningful actually amount, 70% on average. And probably most importantly to us is they actually started closing achievement gaps. Just last month, actually, the What Works Clearinghouse actually just published that we're one of 3 programs, distance learning programs, that actually have been proven to work. But that's all just bragging points on the platform. We're here to talk about how do you use these platforms to do science, right? It's important to actually think about when you actually have a platform, well, in what way do you want to do science, right? So in my world, I have 2 very different pieces of content. I have these things called skill builders, which is this thing that give repetitive practice. You have to get 3 right in a row and you keep going. And then we have these open educational resources, these math textbooks, like Illustrative Mathematics, Open Up Resources. Otherwise, there's this other thing called Engage New York or Eureka Math, and there's this Utah Math one. There's these free math textbooks. Most of our users are actually using that stuff. And so we've been running experiments inside these skill builders, and we've kind of come up with a kind of cool way of doing that. Currently, we actually have 103 experiments actually running inside our skill builders. And right now we're being funded through generous support from the Schmidt actually Futures Foundation, as well as from the National Science Foundation, to actually expand that support so that we actually can run experiments inside our open educational resources. There's this little guy here actually shown here. His name is Chris Lesage. He's a teacher that I met in the state of Maine who was actually using my platform, and he actually represents something kind of interesting. He actually was one of the 60 teachers who actually wrote his own content that actually he wrote feedback messages for every question in his own book. He's kind of important because he kind of represents the best so far condition, that if an experimenter wants to come in and say, hey, I have a better idea that it should actually happen, that experimenter needs to beat actually whatever is our best so far condition. Anyone who's got a platform is going to have some concept like this. They're already going to have some stuff, okay? And they don't actually want to let some random actually researcher come by and say, hey, I want to run experiment X. Okay, and so so in my head, it's really important to actually help researchers do science, but researchers come with actually, they usually come with actually, with two conditions that differ only by a single variable, because that's what researchers do, right? They manipulate one variable at a time. But I as a platform guy, actually have my own best so far condition that I care about. And if those researchers don't beat the best so far condition, then I'm going to tell that researcher, thanks for playing, okay? Maybe don't come back, okay? Because your content didn't beat our best so far. I'm hoping they'll beat our best so far condition. But by the way, our researchers, they don't care about beating our best so far condition. Our researchers, they care about actually manipulating a single variable, and they care about, is there a reliable difference between their two conditions? So I just want to help everyone understand there's a fundamental disconnect between actually what platforms care about and what researchers care about. Researchers don't care at all about getting on the high score list of being the best stuff inside my world, okay? They care about publishing cool results and getting interesting results, but that means well-designed experiments. Anyways, eTrials it means the EdTech research infrastructure to advance learning science. I'll give you some examples of what that means. By the way, we run experiments in two different ways, actually, but almost all of our experiments are embedded in step 2, okay? And most of our experiments are in what we actually say are randomization at the student level. That is actually if two kids are sitting next to each other in a classroom, and of course that's not happening in COVID times, but actually they will be getting slightly different user experiences. If the user experience is so big that they look so different, like one kid has flashing, balloons, then we won't run that experiment actually. But most of the time, the feedbacks or the experiments are so mild that actually we're doing that at the student level. That's where we get all the statistical power, and that's why we do it that way. Okay, so anyways, I think I made my point about the best so far condition. So I'm going to go to, I'm going to actually say that our main goals with our eTrial stuff is to increase the number of studies that we're running and to decrease the time that it takes to run these studies. I alluded to the fact that we have two different types of actually studies. We have studies where the teachers are unaware of what's going on. Okay, if you go read actually the terms of use inside our platform, and if anyone asks me, I actually am very happy, and I tell all our superintendents, we're running studies all the time inside our world. We're trying to always find out what actually works, okay? And those are embedded studies. We have our orchestrated studies where actually teachers are very much aware. If we ask a teacher, here, go actually assign this pretest and then do this and then have this post-test. That's an orchestrated study. We do both of those, but they're super different. The first top, actually the embedded studies, they scale really well, right? Actually, the cost to double the number of subjects costs approximately nothing. But the bottom one is to double the number of subjects costs double the cost, because you got to reach out to even more people and do more. So those are different things. Anyways, I've been doing this for a while. I think I was first doing this all by myself. I think I published 8 studies by myself and students at WPI. Then I started working with and I published a bunch of studies, 14 of them, with external universities. And I'm pretty proud of the fact that 8 publications have now come out that my name is not on them. And in academia, that's kind of weird. These are them. That's not very impressive to look at, is it? So let me just show you one. So here's the most recent one that just came out. Aaron Otmar and Avery Harrison and Smith and Toole actually just came out with this one where they were manipulating something that you'd never think to manipulate. They're manipulating the spacing around multiplication signs and and addition and subtraction symbols. This has to do with how people think about order of operations. Turns out this really matters a lot about how people perceive mathematical equations. Once you start looking at that, so you're like, people care about this? And you're like, no, they really do. Like, this is like a fundamental building block about how people perceive mathematical expressions. This also gets to the sort of point of, which is like, this is kind of a very minor manipulation, but yet it can really help us do some interesting science. I'm going to give you 3 more examples. Emily Fife ran one of the first studies. She was manipulating feedback, whether you got feedback right away or not. Feedback is super important. In fact, she started with the assumption that higher knowledge kids shouldn't get immediate feedback. Turns out she disproved that hypothesis. All kids in her study benefited from feedback. Next example, some of my students and Sydney DeMello were manipulating different motivational messages. There's 3 conditions: a control condition on the far left and 2 conditions that were representing 60-second videos of talking heads of one inspired by a Carol Dweck, that's the lady from Stanford that many of you might have heard of, the mindset lady, versus Peckrin, who's the psychologist in Europe, that's the control value sort of person. There's 2 different videos that one, Carol Dweck is all about you can do it, only you can change, whereas Peckrin is this guy that's all about value, like math is valuable. If you you should care about math because you're going to be able to not get ripped off at the store. Turns out that video was the one that caused homework completion rates to go up. And so I'm agnostic on all this stuff. I run a platform to help people do the science. Third one, oh no, oh right, I guess I gave you my 4. So I think I have 2 more slides. I want to talk about giving out data. So I'm super happy that 46 people, so to my knowledge now, have used our open data sets. We give out these data sets. I'm a big believer in things like open access, open data, pre-registration. So if you want to run a study in our world, we demand that you pre-register it at the Open Science Foundation so people know what you're planning on doing. I will point out that I saw someone in the audience that I think was a Chinese language instructor, and we just related to Ben Motes, who is running a study with Terracotta on Canvas. We were looking at the role of immediate feedback in Canvas classes, this study has a very nice property, which we pre-registered the whole study at the ARA Open Journal. And when you pre-register a report, that means the journal agreed to publish the study before we ran the study. Okay, from an academic point of view, that's wicked weird. Okay, turns out the study came out and had positive results. But anyways, if you get me going, I'll tell you about how Canvas does immediate feedback all wrong. They give feedback at the end of an assignment, not problem by problem. I just want to maybe I made this point before, and I think this is the last thing I just wanted to say, particularly for the platform providers here, to just help you think about. You gotta think about, and as I was trying to help other platform providers think about how you should run experiments, and this might shock Kumar, because you might think that I should be helping these people. When people are saying, hey, you know, this grant is out there saying, hey, I actually should go do experimentation. And I'm like, you know what? You should go do experimentation in areas that you don't care about. And they're like, what? And I'm like, no. Because like lots of these providers have these platforms, okay? And the people that are running them are scared to death. They have people that run their operations and they're like, hey, we're trying to get people to like our stuff, right? And if we actually drive any of our users away, like that's gonna be the kiss of death, right? And we will not have anybody else to actually run experiments upon, right? So I was helping these platform providers think about, ooh, where can you put experimentation that doesn't actually like drive and like, that isn't like at the total core of your business, but allows you to actually, where are the places where you're not, it's not going to be totally threatening to all of your vice presidents that are like going to actually rip your head off if you go try to actually run experiments. I found it kind of surprising to myself as I was actually wanting to actually tell people, you know, because I love running experiments, but I was like, you should think about, and I was helping these people realize, hey, let's go poke around your product actually, and you'll quickly find places where there's plenty of places where you're not actually thinking, there's plenty of places where they're happy to actually realize, oh yeah, you're right. Yeah, I guess I could actually experiment over there. Anyways, I think that's all I really want to say.
Great. So what, I see a bunch of great questions coming in, and folks should feel free to keep adding, and we'll start to go through them. Before we start going through them, I want to just see if Steve is here and he wants to add any more color on the experience that you had on the Kearney Learning side.
Yeah, I'm here. Thanks, Kumar. I've been off camera because I had one of these back-to-back meeting days and I was eating my lunch. So you didn't get to see me do that. Yeah, we've been working on a platform called Upgrade, which, as you mentioned, is an open source platform that runs as an independent process outside of an educational application, but interacts with your application in order to provide support for running A/B tests. And I think one of the things that we're very concerned about as a practical matter in running experiments in educational applications, particularly ones that are used in schools, is what's called group random assignment. So when you're testing out some innovation, like let's say a different, like the slide showed, you know, a different model for teaching fraction division, you want an intact class to all get the same model, so that when a student asks the teacher for help, the teacher knows, oh yeah, you're using this model, rather than having to have individual assignment. And it turns out that that group random assignment is a significant complication with running experiments in schools, because all sorts of other factors play into being able to do that group random assignment. There are a number of other things that we're very interested in. I would say if you're a platform provider and are really interested in understanding how to run A/B tests, we'd love to talk to you. And there's some contact information in the chat already.
Awesome. Well, why don't we start going through the questions? I'll jump around, but people should keep adding. Luke, do you want to ask your question out loud?
Yeah, sure. So mine was about.
Do you want to say a sentence about yourself? Because I think.
Oh yeah. So
my name is
my name is Luke Eglinton. I'm a postdoctoral researcher at University of Memphis, working with Phil Pavlik. And so my work is about making adaptive practice systems, basically using a combination of a learner model to track the student's understanding, and a pedagogical decision rule to decide what to do with that information, to decide what's practiced next. And my questions are is like twofold. So we're talking a lot about A/B tests, which I think kind of imply tweaking like one particular parameter and then observing the effect. And so my question is, given the limitations of that approach, given it's like a pretty highly complex dynamic system we're talking about with these platforms, is there any kind of thought towards manipulating multiple parameters at once or in kind of a parametric way? And then the other question was how deep can these experiments be? Can it be about like manipulating the aspects of the platform itself? Like, for example, the assessment system, practice for a given concept might end if the student gets it correct a few times in a row. Now, it might be that for some students, depending on their aptitude, that's not enough practice, for others too much. And so, but that's a pretty fundamental thing to be changing about the assessment system. And so I'm wondering, like, to what extent are manipulations like that possible?
Great question, Luke. And by the way, actually, thanks. Luke is one of the people that actually has used actually our open data sets actually, and so I'll give you a shout out for that. We do not actually make it easy for actually external researchers to actually run that type of A/B experiment. There's always this problem of actually, as you build out an experimental infrastructure, like what do you want to expose, right? Like I don't allow you to just download all of ASSISTments and go tweak anything you want, right? Like we actually, in order to provide it, we have to guess, what do we think people will actually most likely want to manipulate? And also, what do I want to actually get out of it too, as a platform provider, right? Like I want to get multiple different ways of people providing different types of feedback. We have internally run different experiments on actually different ways of providing space practice, but it doesn't seem like there's thousands of teachers that actually are able to provide different algorithms, provide space practice. So like that is not something that I've decided that's a general feature that I want to provide. Maybe that's something that actually you and Phil Pavlik and I should go write a grant around and go mess around with. But that would be my answer.
And Steve, do you want to quickly answer? And then Luke, if you had any sort of follow-up, and then we can keep moving down the list. Steve, anything you'd add?
I responded to Luke in the chat before. So certainly, like supporting different experimentation patterns, including factorial experiments and kind of multi-arm bandits and other designs that require the experiment to adapt based on data that it's collecting is definitely something that we're really interested in looking into for the future and upgrade. It's not something that we do now, but yeah, Luke, let's talk.
Excellent. Yeah, thank you.
I saw Katerina, you had a question earlier and then a new one. Do you want to say both?
Sure. Yeah, I was curious to learn a little bit more. It seems like the definition that you had put forth was very oriented in like computer science as a field. And I'm curious if there's other theoretical orientations for thinking about learning engineering. And then my second question was about describing the limitations of just collecting data through an online platform versus supplementing with, you know, surveys of students or surveys of their parents.
That's a great question. You know, I would love other folks to weigh in as well. I would say I definitely characterized it more with a computer science lens, but its roots are definitely broader than that. I mean, I think, you know, the broadest definition I've always seen about learning engineering is just, it's the corollary to learning science, which is the application of learning science in the actual delivery. And then that actually pulls in psychology, cognitive science, like a whole number of different related disciplines can have contributions. Part of the reason I focus on computer science is just that's been the lens through which, the sub lens that we've sort of approached it, which is this is the affordance that is most rapidly expanding when it comes to computational talent and methods. And it's one where we draw the most direct analogies, so like the rise of computational biology. But I definitely think there are broader, and there's a number of disciplines that I think have pretty important contributions, and neuroscience and others are going to make important contributions in the coming years. So I will say I was giving like sort of more of like the way we're approaching it than I was giving a field definition. And so if other folks would want to add in Neil or anyone else.
Just because it's done online doesn't mean that actually you don't survey anyone. As a general rule, we actually don't actually allow anyone to just propose, hey, we have 500,000 kids, you want to run any surveys you want. Actually on our population, we don't do that. But actually, we do actually allow actually small numbers of teachers to actually decide to actually participate in small research studies. But just because it's done online doesn't mean that you don't actually survey folks. Anyways, no one's against. I'm not against actually seeing real children in action. I'm just kind of interested in what are the interesting affordances that are possible with these online platforms.
I mean, the only other thing I would sort of add in is I've been really intrigued by the work that, for example, Character Lab has been doing in building a large, test bed that's not predominantly online. And I think one open question, if at least we've asked, is like, what might be intersections between, experiments that are predominantly online or hybrid, and how could you pair them in class? I think thinking about where online experiment, these sort of research experiments that are predominantly on the digital side do transfer, and where they don't is a really good and I think important question. Katerina, did you have anything in follow-up? Otherwise, I'll continue to go down.
Yeah, I just had one follow-up, just because in my experience, I've done a lot of analysis of gameplay data, and I've often felt like without having additional data to contextualize what I was finding, it became it was hard for me to interpret the actions that kids were taking in the game. So that's just where that question stemmed from. But I appreciate your guys' insights.
Awesome. And Steve, how do you guys think about digital experimentation versus in person, given obviously it's not like Carnegie Learning just exists online?
Yeah, I mean, there's this balance you have to strike between doing like large scale experiments, which, you want to minimize the amount of interaction that you have versus kind of smaller scale experiments that collect additional data. And so we've kind of done both. Like we'll work with a school district. So sometimes we'll do a larger scale experiment to get the general kind of results. And then we'll do a smaller scale, like with a district observation or surveys to understand, what's driving an effect that we might see. Yeah.
David Wiley, I think you had two different questions. You want to say them both?
Sure. Well, just first, super fascinating work. Thank you for sharing and having this forum.
Great to see you too.
So the first was about, this approach of saying, well, our terms of service say that we're always running experiments. We have 100 experiments running now. What's the relationship between that and IRB? Like, are those studies that you're actually able to publish? If you're running 100 studies, do you have 100 IRBs? Do you have some giant blanket IRB that lets you run essentially any study you want? How do you manage IRB as part of this process is really the question I'd love to hear you talk about, and Steve and anybody else.
Yeah, so well, here I'll first answer that. Actually, every grant we actually have is actually all this is done through our institutional review board, and we're only allowed to actually run studies that actually fall under the exemption having to do with normal instructional practice. That's why I'm not allowed to actually send out random surveys to actually billions of kids, because that's not normal instructional practice. Comparing actually different hint messages, that's normal instructional practice. So yeah, so that's the thing. So this is not, it's all about that actually fundamental exemption. Steve, do you want to give your answer?
Yeah, one of the weird quirks also with the world is we can run A/B tests as a company. That's not a research study, differently from when we collaborate with researchers and we'll go through an RRB. I'll say one of the things that I'm concerned about large scale studies, I know Kumar and Ulrich have heard about this. Neil, I think I've talked to you about this too. But there's starting to be kind of restrictions on who we can provide data to, even anonymized data under contracts with school districts. And so we're actually in a strange situation now where we can run experiments under normal educational practice, but we can't actually provide the data from those experiments to educational researchers, at least for a lot of the school districts that we work with. So there's some work that we need to do with people who are concerned with data privacy and stuff to enable these kinds of experiments to be done at scale. Like the smaller scale experiments, it's not a problem because you'll get permission from the school districts to provide the data. But if we want to provide a large scale experiment, we're restricted from what we can do with that data.
So can I just say that answer back to make sure that I heard it correctly from Neil? Neil, the way I heard you answer that question was because these are the typical kinds of things that you do in the course of instruction. It's outside the scope of IRB, and you can run and publish these kinds of experiments without submitting each individual one for review.
No, I wouldn't say it like that. Actually, I'd actually lose my job if I actually decided to actually run a study that did not actually, like, I'm legally compelled to make sure it actually falls under what my IRB is saying. If this isn't actually normal instructional practice, then I'd actually be fired for, doing it. So yeah.
Each of these 100 studies you're running, you're submitting them and you're just being told they're exempt. And
yeah, so the yes and no. So meaning actually, the broad outlines of the types of studies are actually exempt, are sent to the IRB about actually, we're comparing text versus video, we're comparing these things, and the IRB says, yep, okay, those look like normal instructional practice.
okay, so I don't mean to beat a dead horse, but it seems like the technology is actually the easy part of experimentation at scale, and figuring out how to manage the IRB in a way that doesn't overwhelm you administratively is a real problem to overcome. So I appreciate you sharing that. Thank you.
Yeah, and by the way, anyone who wants to run a study actually at our at eTrials has to also get their own university to actually submit. They have to submit their own stuff to their own IRB that actually kind of acknowledges they will never actually know anything about these people that actually are part of the studies.
Yeah, and David, this, I think part of the reason for hosting these sort of conversations is I do feel like a number of the institutions we interact with are sort of trying to navigate and trying to figure out. And I think having this being a shared exercise among the academics who are trying to do this work, as well as some of the platforms, I think makes a ton of sense. So I'm glad you're raising the issue. Did you have any others? Otherwise, I'm going to keep going down the list.
No, I've taken more than my share of the time. Thanks.
Awesome. I think Alex, you're up next.
Sure. Hey. So my question was about project-based learning, kind of in the context of a bunch of research coming out showing the effectiveness of that. And so the question just being, in your mind, what's the role of project-based learning within the curriculum? And are there any tools, instruments, or measurements that would, in your mind, improve the efficacy of it?
It's funny, actually. So WPI prides ourselves on actually having actually created the WPI plan and creating project-based learning actually in the 1960s. So I think of actually lots of what we do with assessments as actually supporting jobs of math teacher classrooms, actually supporting project-based learning, largely by letting actually computers do some of the boring actually procedural stuff, so teachers can do some of the more interesting project-based learning stuff. So I don't really think that the computers do the project-based learning stuff. So I'm not sure if you were expecting that, but that's my take on that.
Yeah, no, definitely. I guess the question was maybe directed as what kind of features might be might come to mind in terms of monitoring that may help improve the efficacy of the projects? And then also, I guess, what kind of standardization or process in your mind goes around constructing the projects and like how they are formatted, I guess, if you had any insight on that, but otherwise, thanks.
Yeah, like fundamentally, assessment isn't really about supporting project-based learning. Like, it's not like we have rubrics that really support, like, you know, your 3-hour-long project that a student is submitting and whatnot. So, like, I don't really have a lot to say on that. I will say that actually the closest thing we have to project-based something or other is Kavara has actually supported us actually in the open-ended component of. We've had millions of children answer open-ended questions. Those, if you want to call those a project, they take a kid 2 minutes to answer.
So Neil, I thought Jim had a comment that he dropped in the chat. Jim, do you want to quickly say your comment?
Sure. I know there are a couple of project-based learning platforms that are capturing some data that could be considered instrumentation of the other side. So there's kind of the assessment side, but the actual activities between project team members. So I think there's an opportunity there.
And Jim, while I have you, do you want to just quickly make the point you made around, I know you've been doing some work under Icicle around learning engineering and some of the definitional work that you just want to flag to people?
Yeah, so I put in the chat the link to Icicle, IEEE-icicle.org, and there's a definition that was adopted by Icicle for learning engineering. It does go beyond the analytics part. It gets into human-centered engineering design methodologies and data-informed decision-making and learning science applied to solving problems for learners. I also have a question that I put in the chat, and that is in other engineering domains that are more mature, even though learning engineering is, the term was coined 50 years ago. It's a relatively new field of practice. Other engineering domains have standards and standards of practice and technology standards. And we're just curious what Neil and Steve thought about the future for more standardization for learning engineering.
And before you guys answer, I just want to quickly collect, John, if you want to say your question, and then we'll do a final 1-2, and then I think we'll be at time.
Sure. Yeah, I'll tag on that. What do you think about, is there a kind of in the standardization approach that it seems like any edtech platform really could benefit from having the ability to do improved research within the constraints, I think, that you mentioned, Neil, maybe some concerns. And so I've been wondering, like, is the work that's being done here, is it generalizable? Are there certain components like well-instrumented data or other interventions that are standard that we should be considering if we move forward for other platforms, things you've learned that are like, oh, it's all about the assignment of students, or it's about making sure you can track outcomes, or I think things that we should be considering as we move forward to look in doing this at other platforms, or is it really bespoke because the platforms are so different?
So I don't think we're going to get to the full answer on this, but I think that the nice thing about both those questions, I think, is that to get to where this is going, which is we've gone through this piloting phase, and I think it begs the question of, like, how do we, just like Upgrade as a common plugin, what are ways that we can get to the idea of something that everyone can adopt? And partly that's the point of an AMA like this. So I would love if folks have additional questions to continue to reach out to Ulrich and team. I think we can do more of this, if folks have interest to continue to create dialogue. And so you should definitely let us know if this was interesting, this was useful, and any of that feedback, because that's what will trigger our own continuous improvement and learning on this. And with that, let me just thank Neil for all of his amazing work on this, for Ulrich, Kayla, Meg, and team, and then Steve for unofficially just getting pulled onto the panel.
Well, thanks for having me.
Thanks, everyone.
Thanks, everybody.